What's up, guys? Coach B here. Another episode of Chalk Talks. If you saw the video I posted an hour ago, I guess the audio was messed up, so this is a brand new one. I'm re-recording it. Anyways, today we're going to continue our conversation about options basics, and we're going to start talking about the Greeks. Okay, I think this is the last thing I'll really want to cover before we start talking about actual option strategies. But before we get started, I want to take the time to say, if you're just coming across this video and you feel lost on some of what we're talking about, I made an options basics playlist on the channel today. Check that out. It starts from the beginning, kind of covers everything that we've talked about previously. And as always, if you come across any questions or ideas for future topics, leave them below in the comments. All right, so let's get down to it. There's 4 Greeks that greatly affect option pricing. There's more Greeks than that. But these are the ones I feel like you should really get to know before you start trading options. And those are delta, gamma, theta, and vega. Okay. So first off, we're going to start today with delta. And then we'll get into these other ones in the next video. But delta is essentially the amount an options contract is expected to move as the stock price moves by $1. So when you look at the delta on an options contract, it's basically saying that, okay, if this stock price moves up $1, the contract price is going to go up by the delta. Okay, so the delta amount is going to be different for every strike price, and it's going to be different in every chain, and it's going to continuously change as the options continue to move. For example, let's say you got a stock, it's trading for $10, right? And you're looking at the $12 strike price, and it's 50 cents for that contract, meaning you're going to pay $50 for that one contract. Okay. The delta on that $12 strike that you're looking at is 25 cents. Okay. So that means that if the stock moves from $10 to $11, $1 movement, the price of the contract should move up 25 cents from 50 cents to 75 cents. Okay. Now, once we get to 11, the delta on that strike is going to change. Okay. And, it was at 25 cents. Maybe it's at 80 cents now. So, again, now the stock's worth 11. That strike, the $12 strike, the contract's worth 75 cents now, right? And it's got a delta of 80 cents. So now if the stock moves $1 and gets up to 12, we can expect the contract to be worth $1.55. 75 cents was the original premium. Stock moved $1, so you add the 80-cent delta, gets us to $1.55, okay? And now a new delta will be on there. The contract's going to continue to increase in price as the stock moves up $1, and it'll just keep going, okay? Now, that example I gave was for calls, but it works the same exact way for puts. So let's say, again, stock's trading at $10, and now we're talking puts, so you're looking at the $8 strike. You think the stock's going to go down, and you can get that $8 strike for 50 cents. Every time the stock moves down $1, if the delta's 25, now all of a sudden, if it drops from 10 to 9, moves $1, you're going to be able to add 25 cents onto that contract. So that contract's now going to be worth 75 cents. Okay, and then the delta is going to increase. Let's just say 80 again, for example. So now as the stock moves down to 8, the contract will be worth $1.55. Now maybe the delta moves up to 90. Okay, so now when it moves down to 7, you're going to be worth $2.45, right? $1.55 plus the 90-cent delta. And again, this is all hypothetical, and deltas will increase or decrease at varying rates based on other Greeks too. But this is an example to show you how they work. So let's take a look at the option chain to see some real examples. All right, so you guys know I always like to use Disney as an example. So we're looking at, let me pull up this Disney option chain right here. There we go. And I'm just going to come out here and look at, let's go October 1st, about 43 days out. So right now, let's say the 180 strike, it's going for $3.15. That's the cost of the contract right now for the 180 strike. Okay. And the delta on this contract is 33 cents. Okay, so Disney is trading right now at 173.25, and if it moves up to 174.25, we can assume automatically that this contract is going to add in this 33 cents and now all of a sudden be worth $3.48. Now, once that happens, a new delta will appear. And then if it moves to 175.25, you can add that delta in. That's how your price increases with the dollar with the dollar amounts. Okay. Also notice that right at the money, you usually see, deltas close to about a 0.5. Deeper in the money, you're going to see deltas that are higher, 0.8, 0.9 in that case, and way out of the money, deltas are very small. And we'll get into why it's like that in a second. But it works in the exact opposite way too, right? So let's say we bought this 180 strike and again, the contract's $315. You bought the contract for $315. Now, if the stock moves down in price, let's say it goes to 172.25, you can expect the contract to decrease as well by 33 cents. What would that put us at? Basically $2.87, if my math's correct, I think. But either way, you get the picture, right? It goes up and down, but that delta is going to change. So every time the stock goes up by $1, you're going to get a new delta amount. All right. So let's see here. So now that we have an idea of how delta affects contract pricing as the value of the underlying stock moves in $1 increments, let's talk about other uses for delta. Okay. While it's not an exact method, looking at the delta can give you a small gauge at the probability a strike price has of ending in the money at expiration. So if a strike has a 60.60 delta, it basically has a 60% chance of landing in the money. You'll notice, like I just pointed out, contracts that are deeper in the money have, a 0.99 delta, maybe a 0.96, even a 0.80. And basically that's the percentage, that's a way of gauging the percentage. So something with a 0.99 delta has a 99% probability of landing in the money. 0.80, 80% probability. And they have that higher probability of ending in the money because they're deeper in the money already. Now, the example I gave was for 43 days out. Further out options, like down the chain, let's say you look like, way out in the money, might have a 0.05 delta, a 0.10 delta. And that's basically saying it only has a 5% chance of making it in the money, right? And like I pointed out a second ago, options that are right at the money typically have a 0.5 because you got a 50-50 chance. Okay. It can expire out of the money or in the money. It's right at the money, right on that line. Obviously, this isn't completely accurate, but it's a decent gauge. And for that reason, delta is also used in algorithms when hedging positions. Sometimes people who write call contracts, the seller of the contract, they need to have 100 shares on hand to sell at expiration time, or if the stock is in the money and someone decides to exercise it. So they'll use the delta to gauge how many shares they need to own. So if they write a call contract and that strike price has a 0.2 delta, it has a 20% chance of landing in the money. They may only own 20 shares. Now, as the stock increases and goes up and the delta rises, they'll buy more shares to make sure that they have those shares on hand in case that gets exercised. But that's a conversation for another video. All right, so the next point I want to make about delta is not only does it change as the stock price moves, it also changes as we approach the contract expiration. Okay, so think about it this way. A contract that's 90 days out has more possibility of volatility, right? It can go up or down. It's got 90 days to do it. A contract that's 40 days out has less room for movement. Okay, so that being said, you think about the probability. The more time there is, more probability you have of possibly getting in the money or falling out of the money. Less time, less probability. So let's say you got a $10 stock, $12 strike. If you were to buy the $12 strike, that's a $2 increase or a 20% increase that you would need to get to in the money. So if you have 3 months, the delta might be, let's say, 0.25, which kind of indicates you got a 25% chance of reaching that strike price. However, let's say the stock doesn't move at all. It stays at $10. And as we approach expiration, 2 months go by. Now you only got 30 days left. We're still trading at 10. The delta might decrease all the way down to 0.10. Stock didn't move, nothing changed, but the delta goes down. Why? Now you only have like a 10% chance of getting there because there's less time on it. And then when we get to within a week, the delta might drop to 0.05. Now you only have a 5% chance. And as we get to the day of expiration, maybe it goes down to 0.01. And eventually it'll get to 0 because the contract isn't going to have any time and it's going to expire worthless. Because as time passes, that $12 strike is less and less likely to become a reality before expiration. So the delta is going to decrease with time. It also works the opposite. If you have the $8 strike, stock's trading at 10, at 3 months out, now you're in the money, right? You got stocks trading at 10, you got the $8 strike, you're $2 in the money. At 3 months out, the delta might be 0.8. So you got an 80% chance your stock stays in the money. And now the closer we get to expiration and you're still in the money, let's say the stock hasn't moved at all, it's still trading at 10, and you're sitting there at that $8 strike, you're going to slowly see your delta increase because you're in the money. And that means your probability, your chance of staying in the money is going to continue to go up. So your delta will slowly make its way all the way to 0.99 on the day of expiration, 99% chance of finishing in the money, and then it'll become 100% at expiration with the 1 delta. I hope that makes sense. Okay, so today we covered delta. On the next video, we'll talk about gamma, how it relates to delta, and your options contracts. Then we'll get into theta and eventually vega. And after that, we'll start talking about options, trading strategies, different ways to make money playing options. But I really want to make sure we get these basics down. Hope you enjoyed today's video. If you did, please hit the like and subscribe button. Also, don't hesitate to leave questions below in the comments or ideas for future topics. Again, thank you very much for watching. Also, I live stream every morning in pre-market, usually between 5 and 6 a.m. on the West Coast. But, come log on during pre-market. Find me Talking Stocks with Coach B. All right, have a good night.